So as we've seen, ER models are very simple, they're easy to draw, they're easy to explain, but they can actually get pretty tricky pretty quickly. So let's lay out some of those choices we discussed. We have to decide whether things are entities or attributes. Seems like an obvious thing, but we'll talk about that. We have to decide whether things are entities or relationships. And then for relationships, should they be binary? Should we generate ternary relationships? What about the use of aggregation? So the ER model has certain goals and certain limitations. It allows lots of semantics to be captured, and that's a good thing. If your database schema captures the real world well, and it's constrained in a way that prevents you from entering information that couldn't happen in the real world, that'll help your database more likely to capture correct data, because you'll only allow in things that make sense. And some constraints can't actually be captured in ER diagrams. So we're going to want to refine our logical design that we get out of this conceptual design. That is to say, we'll want to refine our relational schema we compile down to later on after we're done with the ER phase. So not all the constraints that we want to introduce are introducible yet. Some of them we have to wait till we get to relations. Let's look at the first of these trade-offs we talked about, entities versus attributes. Let's consider an example, a simple address. This might be an attribute of an employee's entity set, or it might be an entity of its own, an entity set of its own. Which should it be? And the answer, of course, is that it depends. It depends on the meaning of your application, so semantics, and it depends on usage as well, how you're going to use the data. It may be that there are several addresses per employee, so this would be a semantics issue. An employee might have more than one address. They might have a home, a work, a vacation address, and so on. If that's the case, it simply must be an entity because you have to separate out each of these addresses, and you can only have one attribute called address per entity. So if you want to have multiple addresses, you're going to have multiple entities for those addresses, and then they'll be in a relationship with the employee itself. This comes up in part because the entity relationship model, like the relational model, requires that attributes be atomic. You're not allowed to have a set of values inside an attribute. So you can't have a set of addresses in the address attribute of a relationship set. The address attribute of a relationship set has to be a single value. And so to capture multiple addresses, we need multiple entities. Sometimes the reason that we need an entity instead of an attribute is that we care about structure. For example, in the address, we might care about the city. We might care about the zip code. We might want to pull those out of the address and break the address down into a thing that has multiple attributes. In order to have multiple attributes, we need an entity. Attributes can't have attributes. Entities can have attributes. And again, this has to do with the atomicity of the data model. Attribute types in the ER model have to be a single value. They can't be tuple valued attributes. You can't have nested structure inside your attributes. And so there's no way to say that the attribute address has sub-attributes city and street. Instead, you introduce a new entity called address, and you give it attributes like city and street.